Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In this episode, we'll be adding in fireballs and we will be fixing up our pipes. So right now, our pipes don't really work the best when we go through it. Sometimes it doesn't detect that you're actually on top of it quite right, so we'll fix that up. And we will also implement it so that when you get the Fireball Mario, you can actually shoot fireballs, which we can't do currently. So let's start with the fireballs because that's a pretty straightforward task. When should Mario be able to shoot a fireball? Well, he should be able to shoot a fireball when he's Fire Mario and there's less than 4 fireballs on the screen. I believe that's the way that the original Mario does it, but you could set it to any sort of arbitrary threshold that you wanted. So let's go ahead into the player controller and we'll go and code that behavior in. So I'm inside the player's update, which is getting quite large, but that's fine because it works. So that's all that matters. And then right below where we have our movement code, I'm going to go ahead and say if key listener is key, or I guess we could use key begin press because we only want to do this on the first press, GLFW key E and player state equals player state dot fire, and we're going to say fireball dot can spawn. And this will be a static function on the fireball class that we'll create. And this will basically tell us whether there are 4 fireballs in existence or whatever other parameters you want to create. So let's go ahead and make that class very quickly. We'll just say fireball. And this is going to extend component. So we'll go ahead and import that, or we should be good because we're in the components class. And then we'll just have a static method in here very quickly, which is going to say boolean can spawn. And this will return fireball count is less than 4. And then we'll have a private static variable, which is fireball count, and we'll initialize that to 0. So now we'll just increment this every time a new fireball is created, and we'll decrement it every time one dies or gets off the screen or hits an enemy, whatever it does. So that should be good for that, but we're not quite there yet. So we know we can spawn one now because the players pressed our key, and we know we can spawn it. And by the way, you could change the interaction key to whatever you want. But how do we actually spawn that? Well, we could do it like we spawn any of our other types of prefabricated objects. We'll get the position, first of all, where we want to spawn it. So we'll say position is a new vector 2f. This .gameObject.transform.position. And we're going to say plus, so we're saying .add. This .gameObject.transform.scale.x is greater than 0. If our scale is greater than 0, meaning we're facing to the right, we want the fireball to spawn to the right of us. So we'll say new vector 2f, 0.26f, 0, which was just some good values I found. Otherwise, we'll say new vector 2f minus 0.26f, 0. So what's happening here is we're basically just doing this all in one operation. We're saying if we're facing to the right, spawn a fireball to the right of us, otherwise to the left of us. But we've just gotten the position. We haven't actually spawned anything yet. So we'll say game object fireball equals prefabs dot generate fireball, and we'll give it our position, which will help it generate it in the correct position. And right now that's not existent, but we'll add that in a minute. And then we're going to say fireball dot get component fireball dot class dot going right, which is a variable we will add, equals this dot game object, which I'm going to move this to a new line. This dot game object dot transform dot scale dot x is greater than 0. So if we're facing to the right, the fireball is going right. If we're facing to the left, it should start off going left. And then finally, we have to say window.getScene.add GameObject.toScene fireball. So we've created this new fireball and everything, but we still haven't added it to our scene yet, so that's the last step, and we should be good. Let's go into fireball class real quickly and add this going right variable. So we'll have a public transient boolean going right, and I guess transient doesn't really matter because none of these should ever be serialized, but you can make it transient or not if you wish. And we'll have it initially false. It really doesn't matter since we're setting it as soon as we spawn them in anyways, but that's what we'll do. Then if we go back into player controller, we almost have no errors, except we still need to create this generate fireball method. So let's go into our prefabs class, and then we will go down to one of the smaller rigid bodies that we create, which would probably be best to use the Goomba, because, well, not the Goomba, because he has a walk animation. We will use the flag top because this works pretty good for our method, and fireball is going to be very similar to this. So we'll just rename this generate fireball, and this will take in a vector2f position, which is the position we'll spawn it in the world. So we're going to get the items sprite sheet, which we're already doing there, which is good. And then we're going to get fireball created. So we're going to change this game object to be called fireball. And this is going to be sprite 32, and we're going to give it a size of 0.18f, 0.18f, which was a pretty good size for me. Then we're going to add a rigid body. We're going to set it to dynamic, fixed rotation, continuous collision, and then we're going to add it to our fireball. So everything there should be good. Then we're going to add a circle collider. So I'm actually just going to remove all this. We're going to say circle collider equals a new circle collider. And we'll say circle collider dot set radius to 0.08f, which is half of our scale, or just about half. It's pretty close. And we'll say we'll say fireball dot add component circle collider. And then lastly, we will add in a fireball component, which is just a new fireball, and we can get rid of that and we should be good. Then we can return that fireball. So now if we go back into our player controller, we have no errors, and we should be able to spawn in fireballs every now and then. Right now they're not going to do anything because we haven't really done anything with it. So if we go in and we hit play and we get Fire Mario, we should be able to see that when we get that fire. If we turn to the left and hit E, we should see fireballs spawning in. And you know why we're not seeing it? It's because I forgot the one thing that we needed to do, which was we passed in this position for a reason. So let's use it. We should say fireball.transform.position equals position. Okay, so now that we have that working, we should see the fireball spawn in whenever we turn into Mario. So once again, if we get the mushroom and then we get the flower and we hit E, there we go. You see we get a fireball and it has gravity and everything affecting it. And we should only be able to spawn 3 of them, but we can spawn more than that because we haven't added any logic to handle that yet. So let's go ahead and actually implement our fireball class so that it moves and we don't spawn more than necessary. So once we go into here, we have our going right variable. We also want to get a hold of our rigid body. So we'll get a rigid body 2D RB. We're also going to have a transient fireball speed, which I'm going to set to 1.7f, which works pretty good. And this is going to be very similar to like most of our other rigid body things inside of our game. And then we're going to have a private transient vector 2f velocity, which equals a new vector 2f. Private transient vector 2f acceleration, which is a new vector 2f. Private transient vector 2f terminal velocity, which we'll set to a new vector 2f, 2.1f, 3.1f. And then we're going to have a private transient Boolean on ground variable, which we'll set to false initially. And finally, we will have a float lifetime, which is going to be 4 seconds. So that's how long the fireball lasts before disappearing. We'll import that class very quickly. So we've kind of got all of our default variables here. Next thing we're going to want to do is we're going to say inside of our start method, what do? Well, first of all, we want to add 1 to our fireball count because we've clearly created a new fireball. So we'll say fireball count, not speed, but count ++. That'll add a new fireball. We also want to get a hold of our rigid body. So we'll say this.rigid body equals the game object.get component, rigid body.class. We also want to get our acceleration.y equal to window.get physics.get gravity.y times 0.7f. So we set physics or our gravity to 70% of physics and then all that other stuff, right? Next thing I'm going to do is go into Goomba because we're going to have some pretty similar stuff to the Goomba, everything else, right? Where basically we have our velocity stuff, right? So basically we can just copy all of this for now and then we'll remove what we don't need. So I'll copy all of that. We will go ahead and say override public void update float delta time, paste all that in, and we'll go ahead and we can get rid of the camera because our fireballs will terminate automatically. We'll go ahead and remove this if is dead function. We don't really care about that. Now we do have a going right thing, but we just have it set to our fireball speed instead of our walk speed. And then we'll have this set to our negative fireball speed if we're going right or going left. So we'll have all that set up. We'll make a check on ground function, which will do the same thing that we normally have. And then we want to set our velocity to our terminal velocity if we need to. And it looks like I might have misspelled terminal velocity up here, which it looks like I did. So I'll just fix that typo and we should be good. So mostly the same, except we need our check on ground function. And our check on ground function is going to look like our Goomba AI. So I'm going to go back into there, grab this one more time, go back into here, and we'll paste that right below our update function. So now that error goes away and the player width is the same. We'll just call it the same thing too, because it really doesn't matter. And then our Y value is a little bit different. This is just minus 0.09F. And then our on ground is literally the same thing it always is. Okay. And once again, you could abstract this into like a parent game object, and we might do that in a future episode when we refactor our code a little bit. For now though, this works fine. Next, we'll want to override our begin and end collision functions because they will help us to change our direction and all that type of stuff. So let's go ahead and say game object colliding object, or I guess I'll just call this OBJ because that's a little bit easier. We'll have a contact and we will have a vector 2f contact normal. Now, if you really want, you could like set up hotkeys that auto generate these functions and stuff, which would make your life a little bit easier. But I am not going to be doing that. Okay, anyways, we will call math the absolute value of contact normal dot x. We'll say if that's greater than 0.8f. So if what we hit was hit horizontally, then this dot going right equals contact normal dot x is less than 0. And this should be contact normal. And this should be this dot going right. So basically, if we hit an object to the right, then we want to start going left. So that's what this is basically saying. And it should switch our direction accordingly. Next, we will add in one final function, which is public void destroy, or I guess we could call this die or whatever. This is basically just could be like our fireballs disappear. We'll call it that. So this will just say fireball count minus, and then we'll say this dot game object dot destroy. So this is actually a pending destroy. If you remember, what happens is we mark this for deletion and we mark all of our components for deletion, and then we actually get cleaned up at the end of the frame. So nothing bad should really happen as a result of this. But anyways, we need to know when to disappear. And when do we disappear? Well, we can say if lifetime is less than or equal to 0, then we need to disappear and we'll return. And then we'll say lifetime minus equals dt, just so that we are subtracting that lifetime. So then after 4 seconds has passed, if we haven't died from hitting an enemy, we will die from other things. So if we were to run this now, we should get a bouncing fireball, but it's not going to be that deadly yet because we haven't added in deadliness. So let's go ahead and actually make sure that we spawn it. Well, if I can just hit one of these, and then we'll get in a fireball. And if I spawn this, you'll see that it's not bouncing. So we do have to add that physics in first. And then it does bounce left and right, but it doesn't hurt our enemies. And they also disappear and we can only spawn 4 at a time. So it's mostly got like everything we need. We're just missing a couple other things. We can make it bounce really easily by just checking if we're on ground. If we are on the ground, what we'll do is we'll just say this dot acceleration dot y equals 1.5f. So we'll just say bounce, right? And we'll say velocity is 2.5f. So this should simulate a bouncing motion. So if we run this one more time, then the fireball should bounce. Oh, and you know what the problem is? I said this should be minus 0.09, but I wrote 0.04. Okay, now we should be good. So now you'll notice that the fireball does bounce and it just bounces over our enemies and everything. In the future, that should actually kill the enemy, which we'll be doing in just a second here. But it bounces like it should. The one last thing we could do is it's hitting Mario right now and it shouldn't be hitting Mario. So let's go ahead and fix that by just overriding our pre-solve method. So we'll go ahead and do this and we will call this pre-solve. And inside of pre-solve, we'll just say if colliding object, or I guess if obj dot get component player controller dot class is not null, or we're running into another fireball, so we'll say or object dot get component fireball dot class is not null. Then we're just gonna say disable this contact so that we just go through this contact. So basically we'll just pass through each other. You could get this all set up using collision layers in Box 2D as well, which would do basically the same thing, but we won't be going into that. So now whenever the fireball hits Mario, it should go through him and we should be good. And if it hits another fireball too, they should pass through each other. So basically, if we just spawn in a bunch of these, you'll notice that it just bounced over Mario, and if they hit each other, they shouldn't be bouncing off each other, so we'll double check that one more time. We'll do some more debugging on that a little bit later, but right now we almost have the fireballs working. We just have to add a little bit of logic to our Goomba AI and our Turtle AI, and thankfully it's going to be very simple since we already have death like all figured out and stuff. So literally all we have to do is say inside of our collision method on our Goomba, if obj.getComponent fireball.class. So what happens if we hit a fireball, the Goomba? Well, we say stomp, and we say object.getComponent fireball.class.disappear. So we just make the fireball disappear, and we stomp our Goomba out of existence, and that should be good. And we also have to check if this is not null. So if it has it, then we'll do this. Turtle should be very similar. So let's go into the Turtle AI. The only difference is if inside of our begin collision method, which is right here, we'll say if obj.getComponent fireball.class does not equal null. So if we hit a fireball, then we'll say stomp again, and we'll say object.getComponent fireball.class.disappear. All right, so now our turtle and our Goomba should die if they get hit by a fireball. So let's test that out real quickly too. So our Goomba dies and our turtle dies as well. There you go, guys. So basically we've got this working right. I don't know why that shell is moving so slow. That's something we should probably fix too. So we have some bugs to fix up and everything, but for the most part, the game is working pretty well. We're basically at a state of completion. One thing I'm going to do in this episode too is we'll fix the bugs for our pipes where they don't work very well. It's a pretty simple fix. So let's go ahead and do that really quickly by going into pipe.java. And basically what we're going to do is right now we have our begin collision checking to see if we should be able to enter this pipe, which is really stupid. Because if in your begin collision method, if you're not on the right side of the pipe, then you just don't get to enter the pipe. And that's not what we want to happen. So it's very buggy right now. So we'll remove that switch statement, which will give us a reference to player if we collide with the player, which is good. And then right here where we have all of this stuff, we'll just say or actually and player at entrance, which we'll just check and see if the player is at the entrance of this pipe. So I'm going to go ahead and just copy that, and I'm actually going to move this and statement to the beginning just so that we are consistent. So we're going to do this at each of these. So we're going to check and see if the player is at the entrance to our pipe, and if they are, then we'll say player entering is true. And how does this player at entrance function work? Well, this is going to be pretty simple. So we'll just say public boolean player at entrance, and we're just going to do a very simple box bounds check to see if our player is within the bounds of our pipe and if it is above the entrance. So I'm copying that switch statement because we do have to check each case. And what we'll do is we'll say if colliding player is null, which means he hasn't collided with us yet, then we'll say return false. So we don't want to do anything in that case. And then otherwise we will go ahead and return false at the bottom here too, which just means that we have not been, that the player was not within the bounds. So then we'll get like a min and max bounds for our player and for our pipe, and we'll basically just do a couple of checks. So we'll say vector2f min equals new vector2f this, or actually we'll just say GameObject.transform.position dot sub new vector2f GameObject.transform.scale dot multiply by 0.5f. So we're basically getting the bottom left corner here, right? This is just the minimum of our box bounds, and we will get the maximum as well. So we'll just copy that. And the maximum is basically the same, except we're just adding instead of subtracting. Then we'll also get the player's minimum and the player's maximum. And then we can use these to do checks. So we'll say get player's minimum, which is the colliding player dot game object dot transform, all that stuff, and the colliding player's transform scale. We'll copy that, paste that, subtract, and we'll say player max. Actually, I guess this should be player max, and this should be player min since we're subtracting here. Okay, so now we have the bounds. We have minimum, maximum, and all that stuff. And now we can just go into here and change our if statement to see if the player's at the correct part of our pipe. So we'll just remove all of this actually. And we'll go ahead and remove all this and all of this and all of this. And a box bounds check is pretty simple. If this pipe is facing up, what do we want to check? We want to check if our player's min.y is greater than our max.y. So our player's on top of us is what we're checking. And our player's max.x is greater than our min.x, and our player's min.x is less than our max.x. So basically we're checking to see if our player's between our box bounds and greater than, like, on top of the pipe. We'll copy that because left is basically the same, except we just want to check and see. And actually I'm going to change this to down. So this will be down, and then we'll do right and then left. So this will be left. Okay, so then down is basically the same as up, except we're just checking to see if our player's max y is less than our min y. And we could do less than or equal to as well. And then we check the same things over here. We could change one of these to greater than or equal, just that we're inclusive, but it really doesn't matter too much because it should catch pretty much a good enough of cases where you won't notice. Okay, and then for right, we're doing a little bit different, so I'm actually going to rewrite this. We'll say check if the player's maximum.x is less than our minimum.x. So our player's on the left of us, and our player's max.y is greater than our min.y, and our player's min.y is less than our max.y. And then left will be basically the same, except we just need to flip this. So checking to see if our player's min.x is greater than or equal to our max.x. Okay, so that should just fix up our pipes and make them a little bit better. They should not be as buggy as they were before. So if we just run over and then we just hit the top of that, we should be able to travel through. Okay, but it is still buggy, so I'm still missing something. Okay, and it actually looks like we are good. So the only thing was, basically, if you're on the edge of the pipe, it shouldn't really let you go through. But once you get closer to the center of the pipe, it should let you go through. And that's basically what it was happening there. But you can see that it works pretty consistently. I haven't had too many problems with it, so you should be good. This is another bug we'll be fixing hopefully soon. So you can see I'm a little bit too far to the right there, but then once I get to the left, you can hit it. So you basically just need to be pretty centered on the pipe in order to go through. But that covers it for this tutorial. One last thing I do want to fix too. Go into Debug Draw. And thank you to one of the viewers for pointing this out to me. I'm sorry, I can't remember your name offhand, but this has been broken for a long time and it never really should have. Instead of doing lines.size times 6 times 2, we should just be doing lines.size. The reason I had times 6 times 2 is because I was referencing some old code where I was doing quad generation, and that should fix any problems you've been having with your debug lines drawing things that shouldn't really be seen. So yeah, that should fix that, and now you should be able to have your debugger working a little bit better too, which is nice. Anyways, though, that covers it for this tutorial. I hope you enjoyed it. If you did, please hit like and subscribe, and stay tuned for the next episode where we should be fixing bugs. So we have a lot of bugs to fix. This does not work right? We can't click onto our transform components and stuff. We can still switch them, but we can't click them and drag them. So we'll be fixing that. Our player gets caught on a lot of things, which isn't good. He can get caught on the edges of blocks. So we'll be fixing that. We will also be fixing other smaller bugs and stuff. So yeah, I'll see you then. Thanks.